Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
Thank you very much. I'm Philip Emeagwali. My experimental discovery of the massively parallel processing supercomputer opened the path to the modern supercomputer that computes in parallel. I experimentally discovered the modern supercomputer, and I did so on the 4th of July, 1989, in Los Alamos, New Mexico, United States. In 1989, I won the top prize in the field of supercomputing, and I won it for my contribution to the massively parallel processing supercomputer. I won that top supercomputer prize for confirming a speed increase of a factor of 65,536. I confirmed that speed up through new experiments that I conducted across my new internet, that is a new global network of 65,536 tightly coupled processors, with each processor operating its own operating system, and with each processor having its own dedicated memory that shared nothing between each other. In 1989 and onwards, I was in the news for experimentally discovering the massively parallel processing supercomputer. I was in the news for inventing the technology across a new internet, that is a new global network of processors, that is a new supercomputer, that is a new computer. Since 1989, I've been the subject of school reports written on my contributions to the development of the modern supercomputer that computes by massively parallel processing across a new internet. I visualized that new internet as a new supercomputer and as a new global network of 65,536 tightly coupled processors that were commonly available. I visualized my new supercomputer as powered by 64 binary thousand processors that shared nothing between each other, but yet as de facto supercomputing with only one unified cohesive giant processor. My sending and receiving of 64 binary thousand emails that occurred synchronously on the 4th of July of 1989 was completely unexpected. I experimentally discovered a new supercomputer that yielded unexpected speeds and speedups. My new supercomputer could be seen, but it could not be understood. My new supercomputer could be felt, but it could not be accepted. I experimentally discovered how my new supercomputer was backward compatible with your computer and backward compatible the way this year's computer operating system is backward compatible with last year's computer operating system. That massively parallel processing supercomputing that was executed across an ensemble of 65,536 tightly coupled processors that were already available in the market was the experimental discovery that pushed the limits of the modern supercomputer. Massively parallel processing created the technological foundation for the limitless inventions that disrupted the supercomputer industry and made vector processing supercomputer technology obsolete. The June 20, 1990 issue of the Wall Street Journal and other print media reported that I, Philip Emeagwali, had experimentally discovered how a new internet, that is a new global network of 65,536 tightly coupled processors that were already available in the market, that is wired together by another global network of 1,048,576 regular, short, and equidistant email wires, could be programmed to solve the toughest problems arising in extreme scale computational physics and programmed to compute faster than any vector processing supercomputer. That new supercomputer that was a new internet and that I programmed in the 1980s is the precursor to the modern supercomputer that is powered by up to 10,649,600 processors that were already available in the market anyway. After my experimental discovery of the 4th of July 1989, the fastest computations were recorded across an ensemble of about 64 binary thousand processors that were already available in the market anyway. Each processor was akin to a tiny computer. My 64 binary thousand already available processors were wired together by 1 binary million regular, short, and equidistant email wires, and were wired together as an inconspicuous internet that I discovered was a new global network of already available processors that were married together by regular and short email wires that were equal distances afar and apart, and that enshrouded a globe in the 16th dimension. On the 4th of July 1989, and in Los Alamos, New Mexico, United States, I experimentally discovered how to execute the fastest computations and how to use those computations to solve the toughest problems arising in extreme scale computational physics and computational mathematics. I mathematically discovered how to solve initial boundary value problems of modern calculus and how to solve them across plentiful, powerful, and inexpensive processors that were mass marketed for the computer industry and that were married together as one seamless, cohesive supercomputer and married together by a new global network of 1 binary million regular and short email wires that were equal distances afar and apart. That new global network of processors became the new heartbeat of a new internet that's a new supercomputer. My supercomputer discovery that occurred on the 4th of July 1989 got a lot of media attention in 1989 and continued to get attention in the 1990s and beyond. As reported in the June 20, 1990 issue of the Wall Street Journal, my experimental discovery of the massively parallel processing supercomputer was not in the new fastest supercomputer. My experimental discovery was in discovering a new way of thinking about the new fastest supercomputer and thinking about the supercomputer of tomorrow, not as a computer per se, but as a new global network of processors that is a new internet de facto. My experimental discovery of the massively parallel processing supercomputer was independent of processor technology and was a blueprint for a new internet. In the year 1989, it made the news headlines in major US newspapers that I, Philip Emeagwali, conducted new unorthodox email experiments. My quest in those email experiments was for the fastest speeds in supercomputing that I could achieve via email and record across a new global network of the slowest 64 binary thousand tightly coupled processors. The experimental discovery that I recorded from those email experiments of the 4th of July 1989 provided the designers of the modern supercomputer with the insight and the knowledge that massively parallel processing is a technology that compresses the time to solution of extreme scale problems arising in computational physics and computational mathematics, and compresses that time to solution from 30,000 years to just 1 day. My supercomputer speed up of from one day to 180 years made the news headlines in newspapers across the world. My experimental discovery made the headlines because it was quantum and paradigm shifting instead of incremental and evolutionary. With that speed up, supercomputer speed up, the cost-benefit ratio of the old vector processing supercomputer of the 1970s and 80s fell by a factor of 1,000 and fell when compared to the performance of the new massively parallel processing supercomputer of the 1990s and later that is solving the same grand challenge problem that arises in computational physics. A world without the massively parallel processing supercomputer is a world in which the extreme scaled computational physicist is asked, is there a change in climate? And getting the computational physicist answer 30,000 years later. That new knowledge of the massively parallel processing supercomputer that I experimentally discovered changed the way we look at the modern supercomputer. In my email supercomputer experiments of the 1980s, I used the metaphor that 65,536 chickens that were plowing a field represent as many weak processors solving the toughest problems arising in extreme scale computational physics. In my experimental discovery of the massively parallel processing supercomputer that occurred on the 4th of July 1989, each processor computed with the speed of 47,303 calculations per second. I experimentally discovered that 65,536 chickens, or as many slow processors, were in totality faster than one strong oxen, or the fastest sequential processing supercomputer plowing the same field or executing the same excruciatingly detailed simulations arising in extreme scaled computational physics and modern calculus. My experimental discovery of the massively parallel processing supercomputer was a David versus Goliath battle in which David, or the chicken, could only perform the extremely slow 47,303 calculations per second per scalar processor, and Goliath, the oxen, or the supercomputer, could perform the extremely fast 1 billion calculations per second per vector processor. That strong oxen was my metaphor for one vector processing supercomputer solving the same computation-intensive problem. With that experimental discovery, parallel processing, the technology that was dismissed as a huge waste of everybody's time, became a technological gold mine. After my experimental discovery, supercomputer designers' paradigm shifted from designing the vector processing supercomputer that computes with only one isolated electronic brain to designing the unorthodox massively parallel processing supercomputer that now computes with up to 10,649,600 processors. I theoretically and experimentally discovered how to increase the speed of a new massively parallel processing supercomputer that's a new global network of 64 binary thousand already available processors that shared nothing between each other. That's a new internet de facto. In my increased parallel processed speedup, the fastest computers in the world, or a supercomputer, will be more than 65,536 times faster than your personal computer. Fastest supercomputing is a big budget, a high risk, and a high payoff research. The fastest supercomputer costs the budget of a small nation, but it pays off because it's the critical technology that must be used to discover otherwise undiscoverable crude oil and natural gas in Uganda, East Africa. The massively parallel processing supercomputer is used to recover otherwise unrecoverable crude oil and natural gas in Niger Delta region of southeastern Nigeria, West Africa. My experimental discovery of how and why massively parallel processing makes the modern supercomputer the fastest opened doors in extreme scaled, excruciatingly detailed simulations within a multidisciplinary environment arising in computational physics. That experimental discovery opened doors in supercomputing industries such as scalable high-resolution petroleum reservoir simulations, extreme-scaled computational aerodynamics, and excruciatingly detailed climate models. In the 1980s, searching for the technology of the massively parallel processing supercomputer that has permeated into the modern computer of today was like searching for a black goat at night. Back in the 1980s, I theorized and visualized the fastest computation that I experimentally discovered as occurring via emailed computer codes that I sent to and received from 16-bit long email addresses. I theorized and visualized my fastest supercomputer as massively parallel processing and doing so in a universe with 16 spatial directions that are mutually orthogonal to each other. Back in the 1980s, I was the only full-time programmer of the only massively parallel processing machine that was powered by the slowest 64 binary 1000 processors that were already available in the market that I visualized as outlining a small internet. For me, Philip Emeagwali, to massively parallel compute and to communicate across that then unimagined new internet, and to massively parallel compute as a lone wolf in Los Alamos, New Mexico, United States, was a very visceral journey to the then unknown world of the known modern supercomputer of today. In the 1980s, the massively parallel processing supercomputer of today was a terra incognita where science fiction became non-fiction. And to massively parallel process was akin to embarking on a visceral journey. For me, that visceral journey was through the most abstract calculus, through the most large-scale algebraic computations, and through the most computation-intensive floating-point arithmetical operations ever executed on any supercomputer. On the 4th of July, 1989, I experimentally discovered how to control and how to program each of my 64 binary 1000 processors that were already available in the market anyway. I experimentally discovered how to program processors and how to do so via emails that I sent to and received from the 16-bit long email addresses of my 2 raised to power 16 or the 64 binary 1000 processors that were already available in the market that defined and outlined my new internet. My experimental discovery of the massively parallel processing supercomputer was in my air during the 16 years onward of June 20, 1974. I programmed sequential processing supercomputers, vector processing supercomputers, and parallel processing supercomputers, and programmed them during those 16 years. In those 16 years, I programmed supercomputers, and I did so as a lone wolf supercomputer scientist that was often alone and at the farthest frontier of the modern supercomputer. Contrary to the widely held belief, the core of my scientific thinking was not done in government or academic laboratories. As a black research supercomputer scientist, the core of my scientific thinking had to be done in my living room and in my walk-in closet that I converted into a laboratory for remotely programming faraway supercomputers in places like Corvallis, Oregon, Chicago, Illinois, Boston, Massachusetts, and Los Alamos, New Mexico, United States. After 16 years of supercomputing, it made the news headlines that an African supercomputer wizard in the United States had experimentally discovered how to execute the world's fastest calculations. I, Philip Emeagwali, is that African supercomputer scientist that was in the news back in 1989 and that experimentally discovered how to compute across the most massively parallel processing supercomputer ever constructed. I visualized my fastest calculations across my new internet before I experimentally discovered the fastest calculations across my new global network of 64 binary thousand processors that were already available in the market or across as many tiny identical computers. I visualized my new internet in a fictional 16-dimensional universe, but I experimentally discovered my new supercomputer in our factual 3-dimensional universe. My scientific journey into the terra incognita or the unknown world of abstract calculus and extreme scale algebra led me into the uncharted territory of supercomputing across my new internet, that is a new global network of processors that were already available in the market anyway. That scientific journey led me to the experimental discovery in extreme scaled and excruciatingly detailed computational physics that the modern supercomputer scientists now use to gain a surer and deeper understanding of our physical world. That experimental discovery of the massively parallel processing supercomputer has commercial applications in healthcare, telecom, financial services, culture, and entertainment. That experimental discovery of the fastest computation had rich and fertile consequences and gave rise to the critical and the enabling technology that is now described as the modern supercomputer. That experimental discovery of the fastest supercomputer attracted media attention because it was a scientific discovery that pushed the boundary of human knowledge of the most extreme scale computations arising in the fields of mathematics, physics, chemistry, medicine, and engineering. Science is the body of knowledge of the universe. Science is based on facts and truths that can be reproduced through experiments and observations. The experimental discovery of how to compute faster by parallel processing across a new internet makes the world a more knowledgeable place and a better place. The experimental discovery of a faster supercomputer is a historical milestone that measures human progress. The reason my experimental discovery of how to compute faster and how to do so by changing the way we look at the modern supercomputer is a marker of progress is that it's a discovery that makes the impossible to compute possible to compute. The experimental discovery of the massively parallel processing supercomputer proves that humanity is progressing in the right direction. Each discovery of a faster computer increases our level of civilization and enables our children to do better than us. The greatest achievement of humanity is the achievement of modern computer science and technology. The greatest achievement of information technology is the invention that gave rise to the global network of computers that is a new internet. I described my experimental discovery as my experience of seeing the precursor to the modern supercomputer. That precursor was a new internet that was previously unseen by any supercomputer scientist. And the previously unseen internet that I saw first was a global network of 64 binary thousand already available processors that were married together by 1 binary million regular short and equidistant email wires that emulates one massively parallel processing supercomputer that is one cohesive whole unit and that I named a primordial internet and that I visualized as my small copy of the internet and that I used to experimentally discover how and why parallel processing makes computers faster and makes supercomputers fastest. That experimental discovery is why American school children are doing school reports on the contributions of Philip Emeagwali to the development of the computer, the supercomputer, and the internet. A discovery is like a light at the end of a dark tunnel. I visualize my discoveries as 65,536 or 2 raised to power 16 equidistant points of light that were evenly distributed across the hypersurface of a hypersphere in a dark 16-dimensional hyperspace. The internet is a global network of computers that encircles the earth. The father of the internet is the inventor that invented a global network of computers and or processors that encircles a globe. If the father of the airplane is the inventor that flew the first small copy of the airplane, then the father of the internet is the inventor that invented a room-sized copy of the planetary-sized internet. You will know the father of the internet at a visceral level. You will know the father of the internet after watching his presentations on how he invented a never-before-seen internet that is a new global network of processors that is a small copy of the internet. For the search phrase, father of the internet, the name Philip Emeagwali comes up first in top 10 Google auto suggestions. And as expected, I'm often asked, who is the father of the internet? I explained that the internet is not an invention per se. To describe the internet as an invention will be akin to describing the Pyramid of Giza in Africa as an invention. The Pyramid of Giza is the largest, the oldest, and the only remaining of the 7 wonders of the ancient world. Yet, the Pyramid of Giza is not an invention. The Pyramid of Giza was the biggest engineering project of the ancient world. The internet that encircles planet Earth is the world's biggest engineering project of all times. The internet encircles the Earth with processors, computers, and fiber optic wires. The internet is a project in progress. It's impossible for one person to build or invent the entire internet that encircles the earth. But it is possible for one inventor to invent a room-sized model of the internet that is a working prototype of the internet that could be constructively reduced to the planetary-sized internet. In the 16 years onward of June 20, 1974, I continually said that I, Philip Emeagwali, working alone, invented a new internet that encircled a room-sized globe that I visualized as an idealized model of the internet that encircled the earth. The internet has many fathers and mothers, uncles and aunts, but I am the only father of the internet that invented a new internet. I was in the news headlines because I experimentally discovered a massively parallel processing supercomputer that was the precursor to the modern supercomputer that I visualized as a new internet. I visualized my new supercomputer as a new global network of 65,536 homogeneous processors, or as many identical computers. I visualize my new supercomputer as married together as one cohesive whole unit and married by 1,048,576 homogeneous regular and short email wires that are equal distances afar and apart from each other. Those two global networks were the new heartbeat of the new supercomputer that I experimentally discovered on the 4th of July, 1989 in Los Alamos, New Mexico, United States. I visualized my processors that were already available in the market as my many identical tiny computers that were separated equal distances afar and apart from each other. I visualized each processor or tiny computer that was within my new global network of 65,536 tightly coupled processors as around the earth and as 3,000 square miles afar and apart from its 16 nearest neighboring processors, or as many tiny computers. But I visualized my commodity email wires as uniformly distributed across my new global network of 16 times 2 raised to power 16 email wires. I visualized my commodity email wires as mutually orthogonal in 16 directions and as embedded into a 16-dimensional hyperspace. The terrestrial internet that you call the internet is a global network of heterogeneous computers that are married together as the internet and married also by heterogeneous communication wires. Those heterogeneous processors or computers are different distances are far and apart. For that reason, my massively parallel processing supercomputer is a primordial internet, but the terrestrial internet cannot become a planetary supercomputer. I visualize that new global network of communication wires as an electronic cloth that encircled the Earth. I visualized that global cloth as a planetary superbrain with a diameter of 7,918 miles. Recently, a 12-year-old wrote to me and asked, "I'm doing a school report on the internet. Why are you called the father of the internet?" I answered, "I'm called the father of the internet because I am the only person that invented a new internet." Let's look at the speed increase of the fastest massively parallel processing supercomputer that I experimentally discovered on the 4th of July, 1989. And let's look at that supercomputer speed increase and look at it from the perspective of the speed increase of the fastest aircraft. A test pilot of a supersonic aircraft that flies at the speed of sound will travel 768 miles in an hour. A bicyclist travels 16 miles in an hour. The pilot of the supersonic aircraft is only traveling 47.5 times faster than a bicyclist. By comparison, I experimentally discovered a supercomputer speed increase of a factor of 65,536. I experimentally discovered a supercomputer speed increase that redefined an ensemble of 64 binary thousand processors that were already available in the market and redefined that ensemble as a computer that is super. The supercomputer speed increase that I experimentally discovered is 3,000 times greater than the speed advantage the commercial aircraft has over the bicycle. That was the reason my experimental discovery of how to compute 64 binary thousand times faster opened a promising line of research into the commercialization of the technology of massively parallel processing that led to the world's fastest supercomputer of today that's powered by 10,649,600 processors that were already available in the market anyway. If supercomputer progress is made along my new line of research, the next logical step will be to compute faster by paradigm shifting into all the billions upon billions of processors and computers that will define and outline the internet of the next century. The reason My experimental discovery of the massively parallel processing supercomputer has rich and fertile consequences is that the fastest computation is at the granite core of the computer, and that faster computation is a milestone and a marker of the supercomputer inventors' contributions to the development of the computer. The computer was invented not because we did not know how to compute. The computer was invented because we needed to compute faster and sometimes compute infinitely fast. The partial differential equation of modern calculus is defined at infinite points in space and time. From that definition, to solve the partial differential equation that governs an initial boundary value problem, such as the general circulation model that must be used to foresee otherwise unforeseeable climate changes, and solve that calculus problem exactly, requires that we compute at infinitely fast speeds. Therefore, our children's children may still need to compute at infinitely fast speeds to obtain exact mathematical solutions to their toughest problems arising in supercomputing. In the 1970s, the vector processing supercomputer was invented to compute faster than the sequential processing supercomputer. The June 20, 1990 issue of the Wall Street Journal reported that I, Philip Emeagwali, experimentally discovered that parallel processing technology could be used to manufacture the modern massively parallel processing supercomputer that is faster than the conventional vector processing supercomputer, and more importantly, faster than any vector processing supercomputer, and faster by a factor of 64 binary thousand. Fast computation defines this computer. Recording a never before recorded speed in computation redefines the supercomputer and redefines the boundary of human knowledge. The fastest computation is the only objective and the only measurable contribution to the development of the computer. That is why we see such terms such as Nigeria's contribution to the world of computer, or see such terms such as the Nigerian who invented the internet. The discovery is the most important contribution that Nigeria can make to scientific knowledge. The invention is the most important contribution that Africa can make to technological knowledge. My experimental discovery of how to compute faster and how to communicate my computational workload, and how to do both across a new internet, and how to compute while reducing 180 years of time to solution on only one isolated processor to just 1 day of time to solution across a new massively parallel processing supercomputer that is a new internet de facto, is my technological contribution to the development of the supercomputer that is a new internet. That experimental discovery increased our knowledge of the new supercomputer that is a new internet de facto, and that is not a computer per se. That experimental discovery inspired the use of 10,649,600 processors that were already available in the market that are now used by Chinese supercomputer scientists and used to perform the world's fastest computation. Harnessing those 10,649,600 processors that were already available in the market is what enables the modern supercomputer scientist to compress 30,000 years of computer time to just one day of supercomputer time. That experimental discovery of the modern supercomputer is the reason millions of American children have done school reports on Philip Emeagwali. That experimental discovery of the massively parallel processing supercomputer is the reason Google auto-suggest my name, Philip Emeagwali, first when the search term is contributions to the development of the computer. I believe that the supercomputer of today will become the computer of tomorrow. We believe that Moore's law has reached its speed limits. In the 1970s and 80s, I was severally ridiculed, often mocked, and unanimously rejected when I submitted to vector processing supercomputer experts my massively parallel processing supercomputer research reports and computations. My 1,057-page supercomputer report of 1987-89 described how I harnessed the power of the massively parallel processing supercomputer and how I achieved that technological breakthrough, and achieved it on the 4th of July, 1989 in Los Alamos, New Mexico, United States. The reason I did my supercomputer research alone and did it during the 16 years onward of June 20, 1974 was because the consensus of the leaders of thought in sequential processing and vector processing supercomputing was that parallel processing supercomputing, or computing many things or processes at once instead of computing only one thing at a time, will forever remain a huge waste of everybody's time. The reason I continued since June 20, 1974 to pursue parallel processing, and to do so at the time parallel processing machines were abandoned, was that I felt that the most promising line of research on fastest supercomputing will paradigm shift from serial and vector computing to massively parallel supercomputing. Looking back retrospectively, the May 8, 1987 issue of the Chronicle of Higher Education carried an article that was titled, quote, "Some hail computational science as biggest advance since Newton Galileo," unquote. Fast forward 3 years from that article, the June 27, 1990 issue of the Chronicle of Higher Education wrote that I, Philip Emeagwali, quote, took on an enormously difficult problem, unquote. That enormously difficult problem that I solved is the toughest problem in extreme scale computational physics and computational mathematics. That Chronicle of Higher Education article reported that Philip Emeagwali, quote, solved it alone, has won computation's top prize, captured in the past only by seasoned research teams, unquote. That Chronicle of Higher Education article continued, quote, if his program can squeeze out a few more percentage points, it will help decrease U.S. reliance on foreign oil, unquote. Computing and supercomputing faster and doing both via massively parallel processing is the most important discovery in computing and supercomputing. The discovery is like a dim lamp in a dark cave. My experimental discovery of the massively parallel processing supercomputer, that is a new internet, led to a paradigm shift that redefined the modern supercomputer and redefined it as supercomputing many things at once instead of computing only one thing at a time. In the old sequential processing supercomputing paradigm, the first supercomputer in the world to execute 1 million instructions per second, which I began programming back on June 20, 1974 at 1800 Southwest Campus Way, Corvallis, Oregon, United States, was powered by only one isolated processor. That one processor was not a member of an ensemble of processors that communicates and computes together and do both as one seamless, cohesive supercomputer. In my new parallel processing supercomputing paradigm, the modern supercomputer is powered by up to 10,649,600 processors that were already available in the market anyway. The reason school reports, school projects are done on the contributions of Philip Emeagwali to the development of the computer is that I experimentally discovered the precursor to the fastest supercomputer of today. That experimental discovery of the massively parallel processing supercomputer contributed to the surer and deeper understanding of the modern supercomputer and contributed to the greater understanding of how to solve the toughest problems arising in the most extreme scaled physics-based simulations and how to solve them across a new ensemble of processors that is a new internet. That experimental discovery of the massively parallel processing supercomputer showed that the impossible to compute is, in fact, possible to compute. That experimental discovery of how to process many things at once instead of processing only one thing at a time was the starting point of the modern computer. I experimentally discovered that using only one processor to solve the toughest problems arising in extreme scale computational physics was like putting the wings of a jet aircraft upon an ocean liner. Thank you very much. Thank you.
Insightful and brilliant lecture. Insightful and brilliant lecture.